x plus the cube root of x. Find the antiderivative of that. I'm going to give you a few minutes to do this, to see if you can do this on your own or helping each other out. You have 3 different terms, right? You're allowed to do each one of these individually. Constants in front can come for the ride, right? All right, go for it. Use your power rule. I'll be right back. Yes or no? Think so? Something? All right. Yeah. That's the beginning of the first one there. This has to be rewritten as x to the half. This has to be rewritten as x to what power? 1/3. Okay, so I'm going to bring the -3 next. Well, does anyone have a question on the first one? Brought the 7 for the ride, and then I use the power rule on this. I'm going to increase the power by 1 and then put the reciprocal of that out front. Here, bring the -3 for the ride, and then here I need to add 1 to that power. We did that earlier, right? Notice I'm leaving some space in front of it. X to the 3/2. And then what number goes in front? The reciprocal, right? 2/3, like that. And then on the last one, I just put plus. I need to add 1 to that power. So take 1/3 and add 1, what do you get? 4/3, right? So 4/3. And then what do I put in front? 1/4 or just the reciprocal, 3/4. Done? Plus C, good, plus C. Now I'm going to clean this up also. This is going to be 7/5 x to the 5th minus 2 x to the 3/2 plus 3/4 x to the 4/3 plus C. Does anybody have any good news? I mean, in terms of like checking your answer. There's actually some good news here, isn't there? You can always check your answer and see if you got it right. How? Take the derivative, right? Take the derivative. If the derivative of that gets you back what you started with, then you have the right answer, right? That's good. Any questions? No? How about this one? Let's use a different variable just to make things look worse. Okay, how about g of t, little g of t, equals 1 plus t plus 1/t plus 1/t squared plus 1/t cubed. We want to find capital G of t. Can I do those individually? Yes, I can do them individually. Now, I cannot treat those as fractions. I need everything to be like t to a power, right? So this one I should be able to find the antiderivative of, right? What's the antiderivative? What's the antiderivative of 1? Just t, right? Not x, because our variable here is, yep, yeah. So we should just have t. How about the next one? Antiderivative of t to the first power. T squared, what do we need in I just said it. What do we need in front? 1/2, right? 1/2 t squared. That all right with the first two? On this one, that's really t to what power? -1. Ah, that's the special case, isn't it? If the power's -1, that's the one you have to remember is the natural log. So plus the natural log of the absolute value of t. All right, this one's t to the -2, this one's t to the -3. Those are not the special cases, right? Those you can still use the power rule. So let's see if we can get this one here. Plus, all right, I'm leaving a space in front. T to what power? I take the -2 and I add 1, right? What's -2 plus 1? -1, so I have -1 here. And what do I need in front? What do I need in front? Not half. So whatever powers, like whatever's powers here is going to be the number on the bottom here. So 1 over that number. So I put here 1 over -1. Right? This is my n. That's n plus 1. This is 1 over n plus 1. n plus 1, 1 over n plus 1. The next one plus, all right, what's the power on this one? Add 1, you get -2. And then out front, 1 over -2. Am I done? Let's see. Clean it up. T plus 1/2 t squared plus the natural log of the absolute value of t minus t to the, let me write it this way, 1 over t minus 1 over 2t squared, yeah, plus c. All right, let's see. Do you understand this? This is all the same, right? Here, 1 over -1 is -1, so I just turned this into a minus. And t to the -1, I dropped it down and wrote it as 1 over t. Then here I have plus, this is a negative number, right? So I brought the negative out front. The 2 is on the bottom, and that t to the -2, you can drop it down as a t squared, and I put it on the bottom with the 2. And then plus c. This answer here would be correct as well, but you should be able to clean it up. Questions on that? No? Okay, let's keep going. How are y'all feeling about this so far? Better than optimization? Yeah, better than the word problems? What do you take the derivative of to get that? Sine, right? Not negative sign, right? Sine plus constant. The antiderivative of cosine of x is sine of x. Why? When you take derivative of sine, you get that, right? Plus c. How do you know that? Well, because you know your knowledge of derivatives, right? It's your knowledge of derivatives. What if I put sine here instead? Careful. What's the derivative of cosine x? Negative sine x, right? So we can't use cosine here. We have to do negative cosine. Negative cosine of x plus c. See, we have to put a negative in front because if I took just cosine, the derivative would be negative sine. I want it to be positive sine, so I put a negative in front, and now I get a double negative. So the antiderivative of sine is negative cosine. Let's say that again. The antiderivative of cosine is sine. The antiderivative of sine is negative cosine. Are there any other things that you should remember? This one you should remember. That's a special one. Tangent. Right? The antiderivative of secant squared is tangent. Why? Because you know from Cal 1 that the derivative of tangent x is secant squared x. That's one of the ones you needed to remember, right? Now there's 3 others, but you don't need to worry about those right now, all right? All right, let's keep going. I have another one for you. This one's a nice one. What's the antiderivative of e to the x? What do you take the derivative of to get e to the x? E to the x plus c. Again, that's your knowledge of Cal 1, right? Okay, I think we're ready to transition into the next idea here. All right, you have the basic foundation here for the power rule for antiderivatives. In terms of homework for this, oh, you know what? There's one more thing I want to do. Shoot. Yeah, we should do it. Yeah. This takes up so much time, but we should do it. All right, recall that if, let's see, are they using S of t? Yeah. If f of x is a position function, all right, so let's say I give you a function f of x, and it gives you the position of some object, all right? Then what did we learn about what its derivative meant or represented? What would the derivative of that function be? So position is f. What's the derivative then? The what? What?
Something over time?
Yes. Distance over time, which is speed or velocity. Right? If we have a function that gives you position, then the derivative gives you the instantaneous rate of change of, well, instantaneous speed, right? Slope of the tangent line was the speed of the object. And then the second derivative gives you what function? Y'all are looking at me like we didn't do this. Did we not do this? I feel like we did. Acceleration. Good. Right, this is a big takeaway from Cal 1. You have to know this. If you're given position function, the first derivative gives you the velocity function. The second derivative gives you the acceleration function. Right, so in terms of a picture, if this is some function f, this is time, and this is distance, then that gives you position. If you then take its derivative and graph its derivative, this is time, and this is going to be your velocity. So you get the velocity function. And then if you take the derivative again, a second derivative, this is time, and this is acceleration. So you get your acceleration function. So what we've been doing in this class is we've been going from left to right. I can start with the function. I can take its derivative, right? Derivative. Get the f prime, which is the velocity, and then take the derivative again, right? And I will get the acceleration function. Huh? What we're interested in doing now is starting with the acceleration function and seeing if we can get back to the position function. So can I start here, go back, which means what? Antiderivative, get the position, velocity, go back one more time, anti again, and get the position. Do you think it's possible? What do you think? I mean, if I start with the position, I can take the derivative, get velocity, take derivative, get acceleration. But if I start with acceleration, can I go backwards? Or do we have a problem? What do you think? When I do this first step of going back here, what's the problem? Am I going to get an exact answer? I'm going to have a plus c, right? So it's an infinite number of answers. It's all these functions that are just moved up or down, right? I don't know which one it is. And then I have to go back again, which means I'd have a constant a second time. And which one of those was I using, right? So you have an issue. It's not as easy to go from here backwards. But there is a way, all right? So let me show you. Suppose f double prime of x is, let's go, negative 32. I'm just making this up. That's a constant function, isn't it? So I'm going to try and draw this for you, just so you can see it. I'm going to go draw from the right to the left. So over here, this is time, this is acceleration, and here's negative 32. And the function we have down here is just a constant negative 32. That's f double prime, right? With me? Let's first go back to the velocity function. So that's your acceleration. Let's go back. So let's take the antiderivative, and that should give us our velocity function, time. Okay, can you tell me what the antiderivative of this would be? Wouldn't the antiderivative of this be f prime? Think about it, right? If this is f double prime, then f prime would be, well, what's the antiderivative of negative 32? Negative 32x plus c, right? Negative 32x plus c. With me? Do you all know what that graph is? What's that graph right there, negative 32x? What is the shape of that graph? It's a line, right? It's a line. It has a slope of what? Negative 32. So here's a line. Here's a slope of 1. Here's a slope of 2. Right? Negative 32. It's a very steep line like this, isn't it? Very steep. But plus c means it could be moved up or it could be moved down, couldn't it? Moved up or down. So the only way for me to actually tell you what the c is I have to give you some additional information in the beginning of the problem. So in the beginning of the problem, I say, suppose the second derivative is negative 32. I'm going to add something here. And I tell you that the derivative at 1 is 6. So I'm adding this information because right now we know that it looks like a line like this, but we don't know if it's this line or that line or that line or that line. But it has to have that slope of negative 32. But by telling you that when I plug in 1 I get 6 means that all these lines it could be, right? All these lines that it could be, there's only one of these lines that when you plug in 1 you get 6, right? It's this line right here. Do you see that? That's going to allow me to nail down exactly which line it is. So using this information, using now that f prime of 1 is 6, I know that when I plug what into this, I get 6? 1, right? So let's take that, negative 32. Let's replace the x with 1. Do plus c and say that must equal 6. See, I'm taking my derivative, I'm replacing 1 for x, and then I leave the c, and then I say, hey, that has to equal 6. And that allows you to solve for c, doesn't it? So what's c? C is 38. Add 32 to both sides. The constant must be 38. So that tells me that this is actually f prime of x equals negative 32x plus 38. See, now I know exactly what line it is. But I had to give you this information, didn't I? Without that information, you can't tell me an exact answer. You can only tell me within a certain family of functions. Questions? All right, now let's see if we can go and recover all the way back to f now. So can you all tell me what f would be? F of x. So if this is f prime, find its antiderivative to go to that, right? What's the antiderivative of this? So what are you going to do with this negative 32? It's attached to the x. Bring it with us, right? Okay, what's the antiderivative of x? X squared. You need to kill off the 2, though. 1/2 x squared. Good. 1/2 x squared. Right? 1/2 x squared. And then plus, what's the antiderivative of 38? 38x. 38x. Okay, am I done? Plus c, right? Now, this is the second c I've had in the same problem, right? So we don't like to use c twice. We just use a different letter. So we usually use capital D. That way this and this aren't, you know, we're talking about two different things here. So I don't want to call c two different things in the same problem. Let's clean this up. This is f of x equals negative 16, because that's what 32 divided by 2 is, x squared plus 38x plus d. So do I have an exact answer? Is this an exact function? No, it's a family again, right? So the only way I can nail down what d is if somebody, again, gave me more information, right? So let me go back up and add one more piece of information up here for you. And let me tell you that when you plug negative 1 into the function, you get, let's say, 3. Right? So please understand that when I presented this problem to you originally, when I said, suppose the second derivative is negative 32, and I wanted you to go all the way back to f, that was not enough information. I had to actually provide you more, right? So there's the more I've provided to you. So now I'm going to use the fact that when I plug negative 1 into the function, I get 3. And I'm going to use this line right here. So if I do negative 16 times negative 1 squared plus 38 times negative 1 plus some d that I don't know, that must turn out to be 3. So replacing all your x's here with negative 1's. Square the negative 1, it becomes positive 1, so that stays negative 16. This becomes minus 38 plus d must equal 3. 40, 54, that's negative 54. Plus d must equal 3, so d must equal 57. Add 54 to both sides. Now I know exactly what f needs to be. The function f of x must be negative 16 x squared plus 38x plus 57. I've nailed down the exact function. All right, what do you think? Yeah? So from your homework, what I would do for 4.7 is I would try numbers 1 through 13. I would try all of those. Okay. You can try number 14 if you want. It's a little bit hard, but you can try those. And then (17 through 29) odds. Now let me say something about a few of those. On those problems, these right here, they give you either give you f double prime or they give you f prime, and they're asking you to go either from f double prime all the way back to f or f prime back to f. If you go f prime back to f, you only have to do the antiderivative one time. If you go f double prime back to f, you have to go twice, right? If they do not give you conditions like this, then you will just leave your c in the answer. and then just do the antiderivative again, and then go back one more time, and you'll have a C and a D in your answer. I didn't have time to show you one of those, so if I need to come back next time and show you that, I will. Yeah, let's just do that. What time we got? Yeah, let's just cut class right now. Any questions? Yes?
In a problem like this, will we use capital F or just leave it lowercase?
Leave it lowercase, because what we're doing is we're starting, so what we'd been doing, right, is I gave you little f, we took the antiderivative and we call it capital F. But if I give you f double prime, then when you do the antiderivative, that takes you to f prime, right? And then if you do the antiderivative of that, that takes you to little f.
Oh, okay. Okay, I get it.
So, yeah. It's just, if you do the antiderivative of little f again, what do we call it? Like we're running out of notations, we call it capital F.
Okay. Thank you.
Yep. All right, everyone have a good day. Yes.
So right here on the review, is that just like different notation?
Yep, we haven't talked about that yet.
Oh, okay.
That's coming next class. All that means is take the antiderivative. That's all that symbol means. Have a good day.